So we're going to talk about changing m and b. Now, if you remember from slope-intercept form, which is y equals mx plus b, m is your slope and b is your y-intercept. Slope makes the function move, and the y-intercept tells where the function begins. Okay. All right, so we want to know what happens when the slope or the y-intercept is changed. Okay, so what we're going to do is we're going to graph each function with our calculator, and then we're going to sketch it on the paper or virtual paper here. And then we're going to write the equation with the given change and sketch it in a different color. We're going to analyze how the line changes, okay? All right, so the first function we have is y equals 3x minus 1, okay? So let's graph that. Let's go over here, add graph page. So f1 of x is our fancy way of saying y. So we're going to do 3x minus 1, and then hit enter. Okay, and it goes right there. We're just going to sketch that, right? Looks like that. Kind of like that, maybe. Maybe not, maybe like that. Or like this. Okay, it's kind of what it looks like. Anyway, all right. So then the slope gets changed to -1. Okay, so now our slope is -1, and our y-intercept still stays the same. It's still -1, right? So our new equation is, let me change that color because we're going to change that into a different color. Right, oh, I need an eraser. I'll write all over that. So my new equation is y equals -1x minus 1, okay? So if I hit tab over here, I'm going to do -x minus 1, and I'm going to hit enter. Oh, and it graphs it in a different color. That's awesome. Okay, and so let's do that, -1x. And that's about what it looks like. Okay, that's close. Okay, those are close to what it looks like there. So what happens? How did the line change? Man, it went from positive to negative, and nothing changed where to the y-intercept, did it? The only thing that changed is how the graph moved, or the function moved. Okay, all right, cool. Let's go to the next one. All right, let's do Control Doc to get a new graph page, because this is going to be a whole new thing. All right, so we have y equals -2x plus 4. Let's graph that. -2x plus 4. All right, let's graph that. Oh, that's not going to work. Something like that. We'll just pretend like that's it. Okay. I might erase a little bit of this and like add to it. We'll pretend like that's the same line. Okay. And then now our slope is changed to 1/2. So our slope is now 1/2, but our y-intercept stayed the same at 4, right? So now we have to write our new equation. So it's y equals mx plus b. I'm going to write that first. So I'm just going to replace the m with the 1/2, and then my b with my plus 4. Okay, well, let's graph that. Hit tab. So 1/2, let's do control divide. 1/2. x, can't forget the x, plus 4, and hit enter. Oh, look. Let's see if I can find a purple. That one looks like one. All right, and then that's kind of where it is, right? Somewhere along there. That kind of looks like it. Somewhere like that. All right. It's close. It's not really the right thing, but it's close. All right. So again, the y-intercept didn't change, but the way the function moved did. Okay. All right. So we have a few more. Uh-oh. What happened to this one? This one we have to solve for y. Y is not by itself, right? It has to be by itself. So let's subtract 3x, not 2x. Let's do 3x, not 2x. From this side and this side. So 2y equals 8 minus 3x. Have to divide everything by 2. So y equals 4 minus 3 over 2x. Huh. Well, this slope is negative 3 over 2, and my y-intercept is 4, right? So let's graph that. First, we need to do Control Doc to get another page, add graphs. All right, we have y equals, let's see if we can graph it like that. 4 minus, Control Divide, 3 over 2. Go to the right, x. I bet it'll graph just fine. It sure did. Let's find a green because that's what color it is. All right. Something like that. Okay. So then now the y-intercept changes to 0. Huh. Now our slope stays at negative 3 over 2, but now our y-intercept changes to 0. That makes our equation y equals negative 3 over 2x, because you don't have to write that plus 0, right? Negative, Control Divide, 3 over 2 x, and then hit enter. Oh my gosh, look what happened. What kind of lines are those? We just did some, didn't we? They're parallel lines, aren't they? All right, so what happens? What happened with these? The function didn't move. What moved? The y-intercept moved, right? Okay. I want you to do the next one. I'm going to pause the video, and I want you to do the next one and see how you turn it, how it happens. What happens, okay? Hang on. Okay, how did you do? Did you already know that the lines were going to be parallel? Because what changed was the y-intercept and not the slope? That if the slopes were the same, that they would be parallel? So the only thing that changed was the y-intercept. So that just means that the graph moved up. How many units? It moved up 8 units. It moved up 3 here and then another 5, right? Okay. Do the last one. Let's see how you do the last one. Both things change. So don't be surprised whenever both things change, okay? All right, so I'm gonna pause it again, and I want you to do the last one. Yeah, you have to solve for y first, okay? All right. So Now, both of the things change. So they're not parallel and they don't have the same y-intercept. So the function moved and so did the y-intercept. So both things changed on that one. All right. So let's go down here. Let's come up with a rule for what happens when you change m and b. So when you change slope or m, changing the slope is going to will change how the function moves. Changing the y-intercept or the b will change where the function begins. Okay. All right, y'all. That's it for changing m and b. All right, I'll see you at the next video.